Welcome. In this video we will talk about a Siemens S7-200 CPU and an intro to programming the PLC. The contents of this video are how to create your first program, how to download your program, how to test your program, how to create symbols or variables, how to program timers, how to program counters, and also how to program memories. First, you need to open a program called Step 7 Microwin. There are tons of software for programming PLC. It basically depends on the brand, and even if you have the same brand, the software may be different. However, all PLCs comply with the IEC standard 1131. So in the end, they're very similar to program. So first, let's make a simple buffer. So you will take an open contact. You will select this button over here and select this symbol. Of course, you want it around here. And we are going to use an address. The address is input slot 0.0. Well, let's use input 1. So you write input 0.1. Remember that this is called addressing. This is the way we name our physical variables. Now we're going to take a coil and we're going to use, I'm going to erase this by using my delete key. So now we're going to take a coil, and again we're going to use the name of the output that we want to activate. So we're going to use the Q0.1. Now realize that even if they are the same numbers, 0.1, 0.1, one refers to input and the other one refers to output by the letter Q. So that's it. This is the first program. You use input and you use an output. So now that you have your program ready, we're going to download this to the PLC. To download software into a PLC, you need a way to communicate. In this case, I'm using an adapter, which I'm going to show you later. And also we need to make sure that that adapter is properly configured. For this, specifically for Siemens devices, you're going to go to this icon over here which says Set PG-PC Interface, and you want to make sure that this is properly made. So in this case, the cable I'm using is this one here. I go to Properties and I make sure that I have the proper transmission rate, and I'm going to also make sure that I have the proper connection. In this case, I'm connecting this via USB. So I click OK. Now let's proceed to download the program. You can also upload the program. That is, you can read the current program that is on the PLC and then upload it to the PLC. I'm sorry, to the PC. So to download the program, we are simply going to use this button over here that says download. It will compile our program, and after it compiles, it gives you the option to download. An important part here is that you're not seeing it. I'm going to show you. So here, it's the status of the PLC. So you cannot appreciate it here, but I can tell you that that LED, it's telling me that the program is running. So if I go back and I click download, it will tell me if I want to place the PLC in stop mode. This is important because if you have some sort of process and the PLC is doing something, well, the program is going to stop. So I'm going to click OK. It's going to proceed with the download. Once it downloads, it gives you a prompt asking you if you want to place the PLC in road mode again. So I'm going to click OK. And now we're going to proceed to test the program. To test this program, we have a training station. Let's quickly say it. I have already shown you this, but basically this station has a PLC, which is this one over here, this block. This also has a connection to the computer. The connection is made through this adapter, which is the one we configured before. This also has outputs, which are this over here, which are lights, and it also has inputs, which are buttons. So in order to test the program, we are simply going to press the button. The button is the red one, so I'm going to press it. And you see that the light goes off. So if you remember, we said that we wanted to make a buffer. And this is not a buffer, it is instead a not function. Now, why do we have a not function if in the program we are not inverting anything? We have an open contact and an open coil. This is very important, and that is because even if we're not inverting the input signal in the program is just one part of the whole system. In this case, the physical button, again, you cannot see that, but you can trust me, the button is a normally closed button. That's why even if we're not pushing the button, it is giving me a signal. Hence, it's inverting the signal. So if you pay close attention, you will see that I have some lights over here. So notice those lights. So when I press the button, see that those lights turn off. Well, the light in the bottom. Hope you can appreciate that. And again, that's because even if I'm not pressing this button, the button is sending a signal to the PLC. Once I press it, the signal stops going into the PLC. So to correct this, we're going to simply invert the instruction to get a normally closed contact. So I'm going to create a contact over here, but instead of using the open contact, I'm going to use a closed contact. I'm going to use the same input, I0.1, and I'm going to erase this one here with my keyboard. Now we cannot leave something like this. This is as if it was not connected, so I'm just going to put it together. So we re-download the program. Notice how the light is off now. So if I go and press the button, you will see that now this is a buffer. When I press the button, the light goes on. If I unpress the button, the light goes off. Now we're going to use an animation so that you can see that apart from testing it physically, you can actually see what's going on in the PLC. So you're going to press this button, which is called program status. And what this is going to do is this is going to animate what's happening. So I'm not sure if you're able to appreciate it, but you have a blue light over here. That's telling me that I have voltage over here. Although, remember, this is a program. It's not that you have voltage, but it's the simulation of voltage. So you can see that it is telling me that the input is on. Again, it's on because I have a normally closed contact or button outside the PLC. However, even if it is on, you can see that this contact, it's not letting the current pass. So once I go press it, you can see that the program animates as if it's letting me pass the current here, and it also animates the coil to let me know that now the output is on. Now let's create symbols for our program. I'm going to unpress this button. I'm going to stop the PLC. This is not necessary, but I'm going to do it anyways. And I'm going to go to the section that is called symbol table. So here I can create variables. And variables allow us to better understand our program in terms of what external physical signals we have connected to the PLC. So I know, because how my PLC is connected, that I have some light. I'm going to call it light. I'll have a red light, so I'm going to call it light red. I also have a light yellow. So I have those 5 variables. I'm going to create those 5 variables. Now, this is for me to better understand what I'm doing. So I'm just going to fill the addresses. And for the following programs, we're going to use the symbols instead of the addresses, although it's exactly the same. Again, this is just for better understanding our program. Now we're going to talk about timers. So timers are important elements of PLCs. And we're going to make a program that turns on a light after 2 seconds. So we go back to the program block. We are going to delete this network. So select the whole network and press delete in your keyboard. And we're going to program a new block. So you go here and you're going to find timers. You have different types of timers. Right now I'm going to use the T on timer. So I'm going to drag it. I'm going to put it here. So in order to see how to program the timer, let's go to the help by pressing F1. So here you can see that we have different resolutions. Another name for this is time bases. So in this case, if I want to count 2 seconds, I can go with a higher base. So since I'm using a timer on, you can see here, timer on, and I don't care for a very high resolution timer, I can go with the higher base, which is 100 milliseconds. So if I want to use a 100 milliseconds timer in this PLC, I have the choice to use these timers from timer 37 to timer 63. So what I need to put is, if you can see here, I need to put T and the number of timer I'm going to use. Then I'm going to put MPT, the time that I want to count. So basically I'm going to use timer 37. So I'm going to put here T37. You can see that when I put this, immediately it tells me that it's a 100 millisecond base timer. So if I want to count 2 seconds, I need to put here 20, because 20 multiplied by 100 milliseconds, it's equal to 2 seconds. Now, if I leave it like this timer is always going to count, and I want to count when I press a button. So I'm going to put an input over here, and I'm going to use the black button. Button black. There it is. So you can see that I can put the name, and it automatically tells me which address that name is related to. So now we're going to download the program. I'm sorry, before I do that, I'm forgetting something. I'm not doing anything when the timer finishes counting. So what I need to do is I need to use another input, but in this case it's going to be an internal input, and the internal input is the timer itself. So what that means is that when this activates, this is going to count 2 seconds, and when 2 seconds happen or pass, this is going to turn on. So with that, I can activate a coil and, for instance, turn on the red light. So I'm going to put light, the red one. Now I have the program complete. I'm going to download it. I'm going to animate the program, put it in run mode, and now you can see. So if I go press this one over here, just for a little time, you can see that the light does not turn on, and you can even see the animation that this is activated, but this is not. So if I leave it pressed for more than 2 seconds, then you can see that this activates, and of course the light turns on. Another important part of PLCs are counters. So let's make a program that turns on a light after we press 3 times a button. So I'm going to erase this one here and this one here. I'm going to start a new program. And for that, I'm going to go, instead of timers, I'm going to go to counters. It's over here. I have a lot of counters. So I'm going to go with the CTU. CTU stands for count up. You can see on your screen. So I'm going to put this one here because in this particular example, I'm only interested in counting up. I'm not interested in counting down. So what I'm going to do is I'm going to put again a button over here. And this button is going to be again the black button. So I'm going to put button black. And again, to see how the counter works, I press the help. And here I can see that I have a lot of counters from 0 to 255. And basically that's it. We have a count up input, a reset input, and the number of counts we want to count. So what I'm going to do is I'm going to put a reset. So to reset the counter, I'm going to use the button, but the red one. So I have it here. I'm going to use the first counter, which is the counter 0, and I'm going to count to 3. So that's it. I want to count 3 times with counter 0 every time I press the black button. Again, we need to do something after that, so I'm going to put here a contact with the counter 0, which is going to activate once it finishes counting. And I'm going to put a coil to turn on the yellow light. So I download the program. So now, if I press the count up button, you can see that the counter, it's not counting. So if 1, 2, 3 presses, nothing happens. Now, if you go back to the program, you will see that the red button, it's actually resetting the counter. So that's why it's never counting. And that is because, again, the red button, it's a normally closed contact. So I'm going to stop it. I'm going to change this by a normally closed, the same button. I'm going to erase this one here, connect it, and I'm going to re-download the program. So now if I do the same, you can see 1 time, 2 times, 3 times. And you can see that now that the light is on. Also, I have here a number 3 indicating me that the counter has counted 3 times. I can go press the button a 4th time. You can see that it says now 4, but again, the light remains on. So how do I reset the counter in order to turn off the light? Well, I simply press the red button. It resets and it turns off the light. Last but not least, we're gonna see memories. And memories are crucial for sequential circuits. So let's build a reset dominant latch. And just a comment, no flip-flops are available on PLCs. So I'm gonna erase what I have done. And I'm gonna build the reset dominant memory. So I'm gonna use a comment here. I'm gonna remind you of the equation. So the equation is reset inverted and the set or the memory itself. And this is the equation of the memory. So I'm going to build this function. It has an OR function, it has an AND function, and it has also a NOT function. For this, my set is going to be the black button, and the reset, it's going to be my red button. So in order to build this function, I just need to, do these operations. For the OR operation, I simply connect, two contacts in parallel. So I'm going to put here the set button, the set signal, which is the black button. The memory is going to be a new component that you're going to see, which is a memory. So I'm going to use a memory 0.0. This is an internal bit of the PLC. I'm going to add these two together. So this is an OR operation. To make an AND operation, I simply put contacts in serial. So I put here, now here's an important part. The equation is reset inverted, but remember that the red button it's inverted outside the PLC. So because of that, I'm actually going to put a not inverted contact because the inversion is happening outside. So I'm going to put here a button red. And when this happens, I'm going to put a coil, and the coil is going to be the memory. So that's it. This is my memory. Now, in order for this to do something, I'm going to use again the contact with the memory and a coil with the thing that I want to turn on. So I'm going to turn on the light, the red one. So that's it. I'm going to download the program. Remember, this is a reset dominant memory. So now when I press the black button, I press it. This is as if it was a buffer, but if I unpress the button, you can see that the light remains on. Again, that is because we have a memory. So the only way we can turn off is if I press the red button. So So if I press the red button, it turns off. Now, this is a reset memory because if I press both at the same time, here I'm pressing them both at the same time, the reset is winning because the light is not turning off. That's why this is a reset dominant memory. Now we can also build the same memory with another function, with a specific function that I think it's very useful if you use it right. And I'm going to erase this one here. And I'm going to insert a new network. Insert network. I'm going to insert a new one. So I have two networks. And for that, I'm going to say, okay, the set, it's going to be, again, my button black. And instead of building the whole function, I'm going to use a function that is called set. This over here. So when I press the black button, I want to set a memory, which is the same memory that we used before, M0.0. I'm going to put a 1 here. I suggest that you investigate what this one is. Now, for the reset, I'm going to use the inversion. This is weird. Hopefully you can think of this on your own. But I'm going to use the red button. Again, it has to do with the inversion that is outside the PLC. And I'm going to use the reset instruction. And for the reset, I'm going to reset the M0.0, then number 1. So now that I have the program, I'm going to download it. So now the same happens. If I press the black button, the memory turns on. And if I press the red button, the memory turns off. Now this is a reset dominant memory also. If I press both of them, the light remains off. So I have a little challenge for you. If you can think of how you can build a set dominant function with these two, a set dominant memory with these two functions. Thanks for watching. With these basic components, you can start building your own PLC programs.